Hello students, now we'll discuss about your two theorems that left in your first video, that is your remainder theorem and second is your factor theorem. Now we'll discuss about your first statement of your remainder theorem. So what is your statement? Your statement is, let p of x be a polynomial of degree 1 or more. P of x be a polynomial of degree 1 or more. You can take in place of x in any alphabet, that may be y, z, s, t, anything. Okay, but here generally first is let your variable is x. So this is your polynomial. P of x is denoted by p of x, your polynomial of degree 1 or more, and alpha be any real number. If p of x is divided by x minus alpha, then the remainder is p of alpha. And now recall, in values of your polynomial, we have discussed if alpha is any real number, then by putting in place of x is alpha, then p of alpha is the values of that polynomial. The same way, here alpha is your real number, here alpha is your any real number, and if p of x is divided by x minus alpha, what left? Your remainder left p of your alpha. So now we'll discuss about proof of this theorem. Let p of x be a polynomial of degree 1 or more. Now here p of x divided by this, p of x is divided by this, it means your p of x is your dividend and your x minus alpha is your divisor, because this is divided by this. So this is your divisor, and what we will get? Suppose that we will get your quotient, that is your q of x is your quotient, and r of x is your remainder. Suppose your p of x is dividend, x minus alpha is divisor, q of x is quotient, and r of x is remainder. Then by using your division algorithm, now p of x is equal to dividend is equal to divisor multiply quotient plus remainder. So here divisor is x minus alpha multiply your quotient q of x plus remainder your r of x. So this is your division algorithm. Clear? Now where degree of remainder, your degree of remainder, your r of x always is less than or is equal to the degree of your divisor. Your degree of your remainder always is equal to 0 or less than the degree of your divisor. Your degree of your divisor. Okay, so your divisor what? X minus alpha. It means your degree of x minus alpha degree of x minus alpha is what? Degree of x minus alpha is 1 here. Look here. Here variable is x and here degree of x is 1. So r of x is less than your degree of x minus alpha. The degree of x minus alpha is your 1. So r of x is less than 1. It means your r of x is equal to 0. Less than 1, and that is your 0. Now you put your r of x is putting 0 here. So what left? Now putting r of x is equal to 0, then what left? Now your p of x is equal to x minus alpha into here. So this is your constant. Your r of x is equal to 0. So r of x is a constant. So r of x is a constant shape, and that is your r. Now you say that this is your r constant, this is your r. Clear? Now putting x equal to your alpha here, putting now putting x equal to alpha, now putting x equal to alpha in 1, we get p of x is equal to, it means x equal to alpha, so you put alpha, p of alpha is equal to your alpha minus alpha into your, this your is equal to 0 plus your remainder. This total term is 0. So p of alpha is equal to, and here 0 plus r. So what left? R is equal to p of your alpha. R your what? R your remainder. Remainder is equal to p of alpha. Look here. Then the remainder is p of alpha. So this is your remainder theorem. Now the last theorem is your factor theorem. Now we'll discuss about your second factor theorem. Your statement of factor theorem is, let p of x be polynomial of degree 1 or more, and let alpha be any real number, then if p of alpha is equal to 0, then x minus alpha is a factor of p of x. This is your first point of your factor theorem. If p of alpha is equal to 0, then x minus alpha is a factor of p of x. Then second is just a reverse of your first point. If x minus alpha then P of alpha is equal to 0. This is just a reverse of your first point. Look here, if P of alpha equal to 0, if this is 0, then x minus alpha is a factor. If this is a factor, then P of alpha is 0. So this is your factor theorem. So now we'll discuss about one by one your both points. So now look here. Now your proof of your first point. Your proof of first point. If P of alpha is 0, this is given. This is given. You're giving P of alpha is equal to 0. Then P of x is equal to, by using your algorithm, the same way, just like your remainder theorem, let your P of x your dividend, P of x your dividend, and your g of x, your g of x is your x minus alpha. In this way, your g of is x minus alpha, and q of x your quotient, and r of x your remainder. So by using your division algorithm, your P of x equal to x minus alpha into your q of x plus your r of x. This is by using your division algorithm. Okay, now putting P of alpha is equal to 0. P of alpha is equal to 0. It means P of x is equal to your x minus alpha into q of x. Look here, P of alpha what? P of alpha, your remainder. So this is your P of alpha. This is given P of alpha equal to 0. It means P of alpha your remainder, and this is your 0. So what left? P of x is equal to x minus alpha into q of x. It means your dividend is equal to divisor multiply quotient. Now look here, and this shows your P of x, this is divided by x minus alpha into g of x, then your remainder is 0. If remainder is 0, it means this is completely divisible. So this shows that your x minus alpha is a factor of P of x. This is completely divisible. It means your remainder is 0. So this shows that your x minus alpha is a factor of your P of x. This is completely divisible by your P of x because your remainder is 0. So this is your first point. Now second point is your last point of your factor theorem. Is just a reverse of your point 1. In point 1, your P of alpha is 0, then x minus alpha is a factor. If x minus alpha is a factor, then P of alpha is 0. So now, your second point is, you're giving, what giving? You're giving x minus alpha is a factor. If this is given x minus alpha is a factor, it means your remainder is 0, and this is the proof. So P of x is equal to your x minus alpha into your gx plus your remainder given x minus alpha is a factor. So your remainder is 0. This is showing that. Okay, proving that. So p of x is x minus alpha into your q of x. Now putting x equal to alpha in both sides. So p of alpha is equal to, this is what? This is x minus alpha into alpha minus alpha multiply u q of x. So p of alpha is equal to 0 after putting your x equal to alpha in both sides. So this is the proof of your second point. So both are reverse. It means if p of alpha is 0, then x minus alpha is a factor. If x minus alpha is a factor, then your p of alpha is 0. So this is your factor theorem. So now your chapter 2 completed. So we'll discuss next chapter in next video.